All right, so here we are graphing lesson 5 algebra 2s. And the important thing is that we keep in mind this basic understanding of any time I have an equation, this value out in front represents my stretch or my compression. So here we have a 2, here we have a -1/2, -3. Remember, if it's negative, that represents our reflection. So in this case, with our unit on radicals, we're dealing with the radical. But keep in mind, that could be a parenthesis for a square for a quadratic or a cubic or whatever kind of equation you're dealing with. We have our x as usual, and then we have this idea of left-right movement, and remember, it's always going to be naturally negative. The reason for that is because we can set x minus h equal to 0 and see that the change in our x, our left-right conversation, is going to be h. So that's an important thing to look at. And then we have our plus or minus, our k, and remember, this is our vertical shift, and of course y is equal to k. They're on the opposite sides of that equal sign, so that's clear to see. All right, so when I go to graph these, my starting point is always going to be determined by these values here. So subtract 1 brings me from 0, 0 over this way in a positive direction, and then up 1, 2, 3. So this represents my start, and I get that by a right movement of 1 and a vertical movement of 3. So 1, 3 is going to be my beginning. Remember, when I have a square here for a square root graph, my domain is going to be everything that is positive under the radical sign, so I can't have anything negative. So from this start point and including it up to positive infinity. And then in my range, of course, for my y values is going to be including that value of 3 and then on to infinity. When we say mark clearly 3 or 4 points in each graph, you can go ahead and use your graphing calculator. So if you want to go to clear that out. If you want to go to your graphing calculator and ask it to show you 2 times the square root of x minus 1. Remember, if you have an older calculator, you have to close that parenthesis. If you have a newer calculator, you need to arrow out of the radical sign, plus 3. So when I go to look at a graph, I can see that this 2 is going to make this graph grow larger. So I can go to the table of values. And of course, I see 1, 3, but then I can recognize over 2 up 5 is going to be an integer coordinate, and over 5 up 7. So then I get a pretty good idea of where this graph is headed. It's the square root of these input values less 1, and that is why my graph moves horizontally at a greater rate than it moves vertically. You end up with that flatter graph, but that 2 expands it a little bit. Okay, different conversation now because I have a cube root. When I'm graphing a cube root, I'm going to have all possible values going in and coming out. So important you understand that distinction. When we talk about here, I'm going to go back 1 and up 3. So this was positive, so that puts me back 1. This is positive, so that's going to send me up 1, 2, 3. That's going to be my center point. Without any kind of stretch or compression, I know that these 2 points are also And I know that because of having done a lot of these graphs. So you go to math, you choose cube root of x plus 1. Oops, forgot my x. X plus 1. Make sure you close the parentheses or arrow out of the radical, plus 3. When I look at the graph, now I can see that tail and that tip. And here's where that action happens at back 1 up 3, over negative 2 up 2, over 0 up 4. So I can follow that path of my graph knowing that I have this shape as I go. All right, take a look at number 3. And when I look at 3, I see, oh, we're going to have a compression. So a compression and a reflection of 1/2. So my graph is going to be squeezed in, smaller, hugging the axis. It's a square root. So my domain and range are going to start at a specific spot and then end at a specific spot. Though we're going to look at how that reflection changes it. I have no left-right movement, so my starting and center is over 0, but I'm still going to be up 6. So if I go over 0 and up 1, 2, 3, 4, 5, 6, now instead of my graph going this way, because it's reflection, it's going to come this way. So what's interesting is my domain is still going to go 0 to infinity, but my range, because I'm reflecting it in an up-down manner, my y's are going to be the opposite. My range starts at 6 and goes to negative infinity, so we need to write that from least to greatest. Conversation. Okay, let's take a look at this graph. We'll go ahead and say negative 1 divided by 2, and then we'll go get our radical sign, and our x, close our parenthesis, and then plus 6. So when I look at it, here I am up at 1, 6, and notice how flat it is. If I want to go to the table, try to get a couple points, over 4 up 5, that 1/2 compression is going to make it real skinny. Maybe I can graph 9, 4.5. That'll at least be a third point that I can graph as I look. All right, again, I have a cube root, so we're going to be real smart about recognizing that my domain for my cube root graphs, negative infinity to positive infinity, and negative infinity to positive infinity for my outcome. My starting and center, I have a plus 3, which means I'm going to go back 3, and I don't have anything here, so that's going to stay at my origin. So when I talk about going back, 1, 2, 3, now we talk about this reflection. So instead of my graph going this way, instead it's going to come from here and go down. So that's what that reflection is going to do. This 3 is going to make my points 3 times bigger. So it'll be interesting to see when we go ahead and graph this one. So clear that out, negative 3 times the cube, negative 3, and we'll go get the, that's not what I want. I want the cube root of x plus 3, close parens, and then I want, that's it. So we'll take a look at the graph. Here it is up high, going through our center point and coming down low. Notice that negative 3 stretches it out. It's a lot further away from the axis. We can go ahead and get our points by looking at over negative 4 and up 3 is going to be a point. and over negative 2 down 3 is going to be a point. 11, 6. So if we wanted to come out, that's going to be a point. And then, of course, we can go in the opposite direction and find the one that works out evenly here, 5, negative 6. So when we draw this, we start up high and we come down, and we recognize that it goes on in both directions forever. Perfect. All right, let's take a look at number 5. Graph the function and find its properties. All right, so it's a square root graph. So my starting point is going to be at over 6 up 4, over 6 up 4. My transformation is I'm going to go to the right 6. Remember, it's naturally negative. And then I know I'm going to go up 4. So my domain is going to be all the values from 6 to infinity. And my range is going to be all the values from positive 4 to infinity. My y-intercept, none. And my zeros, none. My increasing interval is going to be from 6 to infinity. There's no decreasing interval. And as x approaches infinity, so does y. Let's go ahead and take a look at this graph and double check our work. So here's my square root of x minus 6, close your parentheses, plus 4. When I take a look at the graph, there it is, and off it goes. When I look at my table, if I put 0 in, that's my y-intercept. It doesn't work out. 6, 4 I have. Here's 7 and 5. And we have 10 and 6. So my square root graph is going to go off in that direction. All right. So go ahead and try some of these on your own. Pause the video and check back in for your answers. All right. How'd you do for this one? It was a cube root with a center point of negative 2, 0. It's a reflection. It's a stretch of 2, and it moves to the left 2. My domain and range are going to be all real numbers because it's a cube function. My y-intercept is going to be when I have an input of 0. So I ended up with a point input of 0, negative 2.52. My zeros were equal to negative 2, 0. My increasing interval, never. My decreasing interval during the whole graph. And my left and right end behavior, as I'm going to negative infinity, my output's going to positive. As I'm going to positive infinity, my input or my output's going to negative. All right, check out 7 and 8. Check back in for answers. Pause the video. All right, when you look at 7, that's a reflection, that's a compression, that's to the right 1, and that's down 3. Number 8, a stretch of 2 and up 7. Number 9, given the graph, what are the transformations from the parent function? And what is the equation? It's nice we get to assume a is equal to 1, so we don't have to do any test points or things like that. All right, so let's take a look at this start point. My start point looks like it is to the left 1. It looks like it is down 3. And look, it looks like it's a reflection over the x-axis. So when I have that equation, I would have my output is equal to my negative. It's a square root graph because it doesn't have a tail. And I know that x goes to the left 1, and then this down 3. Sometimes we can show where our radical ends with a little hook on the end of our radical. I don't see any stretch because if you look, this second dot is 1 away instead of 2 or 3. All right, so let's look at number 10. My center point looks right here. So if I look at my transformation, I went to the right 1. It looks like I went up 5. And it doesn't look like I had any kind of transformations. It's not a reflection, and this isn't stretched or compressed. So I'm just going to say right 1 and up 5. When I go to write my equation, I know it's a cube root because of this tail. My x is going to go to the right 1, and I know that it is up 5. All right, good job. Keep thinking and working and doing your homework.